Given that f of x equals ln x log x, on the same sketch on the same diagram the graphs of y equals f of x and y equals a half of f of x plus 3. Label the coordinates of the point of intersection of each of the graphs with the x-axes. Indicate the behavior of each of the graphs for large positive and negative values of y. So here's the question summarized then. Let's just draw an axis. So we've got our axes here then. The first thing we need to do is sketch log of x. So let's do that. And I'm going to use a dashed line because it's easier for me to draw that with a digital pen. So the log function is just the exponential function just turned on its side. So it shoots up here like so, doesn't it? So there it is. That's the log function. So this is f of x. And as for large, so where does it cut the axes? Well, here log of 1 is 0, and that's f of x. And as x tends to infinity, fx, it tends to infinity as x tends to infinity, and not defined, and x has to be greater than 0, of course, here. Okay, so that's where the y values go to. As x tends to infinity, the y values get large. Okay, good. Large values as x is large, yeah, that's fine. And half f of x fx plus 3. Well, here if we put f1 in, we get log 1 is 0. So if we put f minus 2 in here, it's as though that value. So basically, we've got to go back here to minus 2, and we've got to draw this same curve here. That's shifted over. So what I'm going to have to do is move the curve now. So we'll move that somewhere more convenient. And now we'll move this plot over slightly so we can give us a bit more room on the negative side of things. So what are we looking at then? Let's go back a bit more than that. So I'm going to try and draw the axes here, and I'm going to mark off minus 2 here, say. But basically, the 0 value, which is asymptotic here, shifts back 3 units, doesn't it? Because this point shifted back 3 units. So this axis shifts back to minus 3. So let's just draw that in as well. And that's that line is an asymptote to this curve, isn't it? So this is the value minus 3. So this curve shifts back here and goes up through there, but basically it's only half as high. So it doesn't. So it's a bit shallower because it's half these values, and it's a bit shallower than that. So I'm going to try and draw it being a bit shallower in terms of where it goes. Like so. So it's up a bit, and then it's going to be down a bit, isn't it? So it's going to be a bit flatter. Like so. There we are. And this is the curve a half fx plus 3. And for this curve, I'm just going to mention large y, indicate the behavior of these for large y. X plus 3, half lots of, tends to infinity for large x. So as this tends to infinity, then x tends to infinity. Okay, so that's that one, and as x tends to minus 3, y tends to minus infinity here. Down here, as x tends to minus infinity, whereas this one, as x tends to 0, this curve here, x tends to 0 from above, y tends to minus infinity, isn't it? Okay, I think that's everything said then for the large values of the y values and what happens to the x values. And here's the sketches.